Hello students and welcome to Chemistry B. I'm Miss Slate and today we're going to be talking about the concentration of solutions. So we're going to talk about how we describe concentration as well as how we calculate concentration by a variety of methods because there's multiple ways that we can determine concentration. And we'll also do some problems with dilution. So if you had a particular stock solution and you wanted a certain amount of a different concentration, how would we figure out how to do that? So first off, again, some more terms. A solution is considered concentrated when you have a relatively large amount of solute dissolved in the solution. And a solution is considered dilute when you have a relatively small amount of solute dissolved in the solution. So these aren't absolute terms, these are like relative and comparative terms, right? So like if you had two solutions of the same solute and solvent, you could describe the one with more solute as concentrated and the one with less solute as dilute. So again, in our last video, we talked about the difference between a saturated and an unsaturated solution. Unsaturated just means we can dissolve more solute into the solvent. A saturated one is one that holds the maximum amount of solute at that given temperature. What we're going to look at now is a little demonstration that involves sodium acetate. Because another one of the terms that we talked about yesterday was a supersaturated solution. So you can see we have a relatively small amount of distilled water in our graduated cylinder and a relatively large amount of sodium acetate. And we're going to add the water to the sodium acetate. Now, at regular room temperature, this is not going to be enough water to dissolve all of that sodium acetate. Not even close. But we know for solids that at higher temperatures, we can dissolve larger amounts of solute. So after about 5 minutes of heating, we can see that we've got a good amount of the sodium acetate dissolved, but not all of it. Then after about 10 minutes of heating, we've got a little bit more of our sodium acetate dissolved. But again, we're still not quite completely dissolved. Then after about 15 minutes, we can see that the solution looks relatively clear now. And we have successfully dissolved all of that sodium acetate in just a very small amount of water. Now, at this high temperature, this solution is considered saturated. When we let that solution of sodium acetate slowly cool back to room temperature, once it's at room temperature, it becomes what we call a supersaturated solution. And supersaturated solutions are pretty unstable. They're going to actually go back to being a solid if you just disturb it slightly. So if you added a little bit of a seed crystal or you like jolted the solution, it would go back to being a solid. Now let's talk about concentration. All right, so one way to calculate concentration is by percentages. So we can determine concentration as a percent by mass. It's just mass of solute divided by mass of solution times 100. Or we can do it as percent by volume. So volume of solute divided by volume of solution times 100. So just like any percentage, it's just the part divided by the whole. So let's look at an example here. Our example says, in order to maintain a sodium chloride concentration similar to the ocean, an aquarium must contain 3.6 grams of sodium chloride per 100 grams of water. What is the percent by mass of sodium chloride in the solution? Well, remember, percent by mass in this case is going to be the mass of the solute, which in this case is the sodium chloride, divided by the mass of the solution, and then times 100 to make it a percent. Well, the mass of our solute is 3.6 grams of sodium chloride. The mass of our solution is going to be the combined mass of the sodium chloride and the water. So that's going to be 103.6 grams of solution. And again, times 100 to make it a percent. And we end up with a solution that is about, again, rounding to sig figs, 3.5% sodium chloride by mass. We can also describe concentration of solutions in terms of molarity with the symbol capital M and molality with the symbol lowercase m, okay? So molarity and molality, not only do they have similar sounding names, they are similar ways of describing concentration, although subtly differently. So molarity, big M, is the moles of your solute divided by liters of solution. So moles over liters. Molality, little m, is also your moles of solute, but this time divided by kilograms of solvent. So this is moles per kilogram. So molarity is moles over liters. Molality is moles over kilograms. Additionally, molarity talks about liters of solution, so the entire thing, where molality is dealing with kilograms of solvent, so just the thing that is doing the dissolving. So let's look at some examples here. So our first example says, in the lab, a student adds 4.5 grams of sodium chloride to 100 grams of water. Calculate the molality. Well, again, remember molality, little m, is our moles of solute divided by kilograms of solvent. Well, they gave me mass of my solute and mass of my solvent. So before I can do the molality calculation, I'm going to have to do a little bit of converting. So the first thing I'm going to have to do is figure out my moles of solute. And that's just going to be some basic stoichiometry to go from grams to moles for sodium chloride. So some basic stoichiometry allows me to determine my moles of solute. Now, specifically, they're giving me my mass of solvent in grams, but I need it in kilograms. So I'm also going to have to do a basic metric conversion, right? So I've got my moles of my solute, my kilograms of my solvent. So I can put those numbers into my molality equation and solve from there. And we get a concentration of 0.77 molal. And you could do a similar type of process to determine molarity. But again, just remember molarity is going to be moles of solute divided by liters of your solution. So subtle difference with those two formulas. Got to make sure we know the difference between them. Lastly, let's talk about diluting solutions. So this is something that is done commonly in chemistry labs because many substances come from the chemical company as like a concentrated solution. But rarely, especially in a school setting, do we ever really need concentrated of a particular substance. So thinking of something like hydrochloric acid. Hydrochloric acid comes as a concentrated stock container that has a molarity of 12 moles per liter. Rarely do we ever actually need concentrated hydrochloric acid in our labs. We usually need something much more dilute. So in this experiment, what they really need is they need 435 milliliters of just 2 molar hydrochloric acid. Well, how much of the concentrated hydrochloric acid do we need to dilute to make that? Well, luckily for us, answering those questions is very easy using our dilution equation. So it's just the molarity of the starting solution times the volume of the starting solution will be equal to the molarity of your ending or dilute solution times the volume of that dilute solution. So let's do out that calculation, right? So first off, our original solution is 12 molar. And we want a solution that is 2 molar and 435 milliliters of it. You can stick that one right there on the table too. Yeah. So I'll take my 12 molar stock solution for my M1. V1 is what I'm trying to figure out. I'm trying to figure out how much of that stock solution I need to use. My M2 is the concentration that I want, 2.0 molar, and V2 is the volume of that dilute solution that I want, 435 milliliters. And so then I would just rearrange this, I would just solve this equation for my first volume. And when I do that calculation, it turns out I'm going to need 72.5 milliliters of my original stock solution. So figuring out dilution problems is very, very easy. And that wraps up our discussion on concentration. So when it comes to concentration calculations, you need to be able to determine concentration by percent by mass or percent by volume. You also needed to be able to determine concentration in terms of molarity and molality. And you also need to know how to be able to solve dilution problems.